Nature, it seemed, had plans for this lineage of avian predators, and those plans involved getting bigger, much bigger. Just 3 million years after Paleopsilopterus took its first steps, Eluthaornis, a terror bird that stood 50% taller than its ancestor, emerged as a formidable predator. But Eluthaornis wasn't content with merely growing in size. It also expanded its range in a way that no other terror bird would match. While most of its kin would remain firmly rooted in the Americas, Eluthaornis spread its wings and ventured across the sea to Europe. Fossil remains of this globe-trotting terror have been found in both France and Switzerland, making it the only known member of its family to have lived outside the New World. I can only imagine the surprise of early European mammals when this exotic predator appeared in their midst, bringing a taste of South American terror to the Old World. But Eluthaornis was just the opening act. As the epochs rolled by, the terror birds continued to grow, adapt, and diversify. It was as if they were engaged in a relentless competition with themselves, each new species trying to outdo its predecessors in size and ferocity. The Oligocene epoch, spanning from about 34 to 23 million years ago, marked a turning point in the terror bird saga. It was during this time that the family truly began to live up to its name with the emergence of giants that would have given pause to even the bravest of prey, the Paraphysornis. This Brazilian bird was an absolute behemoth that stood 1.4 meters, or 4.5 feet tall, and tipped the scales at a whopping 180 kilograms, or 400 pounds. To put that into perspective, Paraphysornis outweighed the largest living bird today, the ostrich. This was no lightweight contender. Paraphysornis was built like a feathered tank with robust bones that spoke of raw power. Paleontologists believe that Paraphysornis hunted using a combination of kicks, slashes, and powerful jabs with its sharp beak. It's a hunting style that might remind one of a prehistoric version of mixed martial arts, with Paraphysornis as the undefeated heavyweight champion of its time. But Paraphysornis wasn't just a mindless brute. Like many of its terror bird kin, it likely possessed a level of intelligence that set it apart from other contemporary predators. Studies of terror bird brain cases suggest that they had well-developed visual and auditory centers, indicating keen senses that would have made them formidable hunters. As impressive as Paraphysornis was, it was merely setting the stage for what was to come. As we step into the Miocene and Pliocene epochs, spanning from about 23 to 2.5 million years ago, we encounter the true giants of the terror bird family. These were creatures that pushed the boundaries of what it meant to be a bird, reaching sizes that rivaled the predatory dinosaurs of old. 3 names stand out in this pantheon of avian terrors: Titanis, Kelenken, and Brontornis. Each of these genera represents the pinnacle of the terror bird lineage, and each had its own claim to fame. Titanis, the youngest and smallest of the trio, was also the most adventurous. While most terror birds were content to dominate South America, Titanis had grander ambitions. It crossed the newly formed land bridge connecting North and South America during the Great American Interchange, becoming the only large South American predator to successfully establish itself in North America. Unlike most of its relatives, this bird lived in what is now the United States, including the states of Texas, Florida, and California. Standing 2 meters or 6.6 feet tall, Titanis would have been an imposing sight for the mammals of North America. Imagine the shock of a Pleistocene horse or ground sloth, accustomed to watching out for saber-toothed cats and dire wolves, suddenly confronted by this alien predator, half bird, half nightmare. But as impressive as Titanis was, it was dwarfed by its cousins back in South America. Kelenken, named after a mythological Tehuelche spirit, stood a towering 3 meters, or 9.8 feet tall, and weighed around 250 kilograms, or 550 pounds. This was a bird the size of a grizzly bear, with a head larger than that of a horse and a beak that could crush bone. The terror bird skull. It's a phrase that stays with me. Its weight likely made it slower than its more nimble cousins, but what it lacked in speed, it more than made up for in raw power. I picture Brontornis as the tank of the terror bird world, capable of steamrolling over any prey unfortunate enough to cross its path. While the giant terror birds, like Kelenken and Brontornis, may have relied on their size and power to dominate their environments, many of their relatives chose a different path. Speed, it seems, was just as important as size in the terror bird playbook. Studies of terror bird leg bones have revealed a structure remarkably similar to that of modern-day ostriches. Short thigh bones paired with elongated lower leg and foot bones. This is a clear indicator of high-speed running ability. Paleontologists estimate that many terror birds, including some of the larger species like Titanis, could have reached speeds exceeding 30 pipeltis, or 48 km/h. That's faster than Usain Bolt, while standing twice as tall and weighing several times as much. But speed wasn't just about chasing down prey. For many terror birds, especially the smaller and medium-sized species, it was also a crucial defensive adaptation. In a world filled with other large predators, including giant carnivorous mammals and enormous crocodilians, the ability to make a quick getaway could mean the difference between life and death. This combination of speed and size made terror birds versatile predators, capable of adapting to a variety of hunting strategies. Smaller, faster species might have specialized in chasing down swift prey, like small mammals and reptiles, while the larger, more powerful species could have employed ambush tactics, or even taken on larger, more dangerous quarry. While their imposing size and fearsome beaks often steal the spotlight, the true power of terror birds lay in their highly developed senses. Recent studies of terror bird skulls and brain cases have revealed that these prehistoric predators were equipped with sensory capabilities that put them leagues ahead of many of their contemporaries. While terror birds might not have had eyesight quite as sharp as modern raptors like eagles or hawks, they were far from being visually impaired. Their eyes were well developed and positioned to provide excellent depth perception, a crucial advantage for any predator. But what really set terror bird vision apart was its versatility. These birds were equally adept at seeing in bright daylight and in the dim light of dawn and dusk, making them effective hunters around the clock. As for their hearing, the inner ear structure of terror birds suggests an acute sensitivity to low-frequency sounds. This ability would have allowed them to detect the footsteps and movements of potential prey, even when hidden by dense vegetation. Imagine a terror bird standing motionless in the prehistoric forests of South America. its head cocked slightly to one side. To a casual observer, it might appear to be resting, or even dozing. But in reality, every fibre of its being is alert, its incredibly sensitive ears picking up the faintest rustle of leaves or the softest patter of tiny feet. In an instant, it can pinpoint the location of its unsuspecting prey and launch into action. This combination of visual and auditory prowess made terror birds the complete predatory package. It's no wonder these birds were able to dominate their ecosystems for millions of years. But even the mightiest rulers faced their downfall. And the reign of the terror birds was no exception. For millions of years, these avian predators had ruled supreme in South America, developing into a diverse array of species that filled various ecological niches. But somewhere along the line, their luck ran out. Traditionally, the extinction of the terror birds was linked to the Great American Interchange, a major paleozoogeographic event that occurred about 2.7 million years ago. This event saw the formation of the Isthmus of Panama, creating a land bridge between North and South America. As a result, animals from both continents were able to migrate across this newly formed connection, leading to a significant reshuffling of fauna. The conventional wisdom held that the influx of new predators from North America, including cats, dogs, and bears, outcompeted the terror birds, leading to their eventual extinction. It was a neat and tidy explanation that seemed to make perfect sense. However, as is often the case in science, the truth has turned out to be more complex and nuanced. Recent studies have cast doubt on this simple competition-based extinction model, revealing a more intricate tapestry of factors that led to their demise. The terror birds. For years we believed they vanished about 1 million years ago, but recent fossil finds have dramatically changed that story. Some smaller species may have lived as recently as 96,000 years ago. And then there's the tantalizing possibility of an unidentified species surviving until only 18,000 years ago. What if terror birds survived almost until humans arrived in South America? It makes you wonder, how close did we come to encountering these giants? One of the biggest challenges to the idea that competition with placental mammals doomed the terror birds comes from the fossil record itself. Most terror birds, and many of their South American competitors, disappeared long before placental predators arrived in significant numbers. It suggests something else was at play. And then there's Titanis, thriving in North America. It coexisted with large canids and felines for millions of years. Clearly, some terror birds were more than capable of holding their own against mammalian predators. So, if competition wasn't the sole reason, what was? As is so often the case in paleontology, it likely involves many factors. Climate change, I suspect, played a significant role. From the Oligocene to the Pliocene, the Earth's climate was on a long, slow, cooling trend, leading to a series of ice ages. This global cooling would have profoundly impacted the ecosystems where terror birds lived. As temperatures dropped and habitats changed, the lush forests that many terror bird species relied on would have given way to more open grasslands. While some terror birds may have adapted, others would have struggled. The larger, more specialized species might have found it difficult to find enough prey to sustain their massive bodies in these changing environments. And the influx of new competitors from North America, while perhaps not the primary cause of extinction, would have added press to already stressed populations. Despite these challenges, the terror birds were remarkably resilient. These recent discoveries, pushing back the date of their extinction, paint a picture of animals that fought to survive in a changing world. This revised timeline raises some intriguing questions. What would an encounter between humans and terror birds have been like? Could there be any truth to the legends of giant birds that persist in South American folklore? While direct interaction is unlikely, the possibility that our ancestors heard stories of these creatures passed down through generations isn't entirely far-fetched. Other megafauna that coexisted with early humans, like woolly mammoths and giant ground sloths, left lasting impressions on human culture and mythology. Larger males typically weighed upwards of 400 kilos, making them contenders for the title of largest felines ever. Judging from the enormous size of these giants, it's easy to assume that tigers have always been this large. But history tells us something completely different. Early tigers, existing long before the Nyandong tigers, were notably smaller in terms of body size and weight. This smaller stature could be attributed to the available prey and the ecological niches they occupied. A smaller body size offered energy conservation and agility advantages across various terrains. Early big cats related to tigers, such as Panthera paleosinensis, likely averaged around 70 to 120 kilograms in weight. Following them was the Trinil tiger, popularly believed to be the ancestor of all known Indonesian subspecies. I've always been fascinated by the idea of apex predators. Imagine ruling the wild, sitting right at the top of the food chain. Life at the top has its perks, of course. But even the most fearsome hunters aren't always the biggest beasts around. When it comes to the predator game, size isn't everything. Yet, every so often, nature outdoes itself, creating a carnivore so specialized, so perfectly adapted to hunting big game that it seems almost mythical. The Nyandong tiger, for instance, existed from the early to the middle Pleistocene epoch. Remains were discovered in Java, Indonesia. As time progressed, this tiger held its own, weighing in at a range of 200 to 350 kilograms. This gradual increase in size over the years can be explained, I think, by the intense competition for food among large carnivores. They needed to eat more and gain more weight to compete for that apex predator position. But the Nyandong tiger wasn't alone in its quest for dominance. It faced competition from other carnivores like the Smilodon, giant hyena, and even dire wolves. The Smilodon, for example, is known for its long, slender canines that could reach up to 12 inches. I can only imagine the deep wounds they could inflict. In contrast, the Nyandong tiger possessed more typical, robust canines similar to modern tigers, ideal for crushing bone and delivering powerful bites, though less specialized for deep punctures, which wasn't always effective considering the enormous size of prey back then. When it comes to size, it appears that they were evenly matched, at least with the largest species of Smilodon. The Smilodon populator weighed between 220 and 436 kilos and stood 120 centimeter tall, which is not that far off from that of the Nyandong tiger. A less formidable rival for the Gandong tiger would have been the giant short-faced hyena, which stood about 90 to 100 centimeters at the shoulder and averaged 110 kilos in weight. However, a group of animals that the Gandong likely wouldn't have dared to infiltrate were the dire wolves. Though they had smaller jaws and weighed way less than the Gandong tiger, they hunted in packs of more than 4 individuals. As a solitary hunter, it would have been difficult for the Nyandong tiger to match that intensity when attacking prey. This placed it at a disadvantage in the competition for apex predator status. Around this time, early humans were notably prevalent in Southeast Asia, with over 80 individual remains found in that region today. So, it's likely that they would have crossed paths with the Ngandong tiger. It is easy to assume that such encounters would have been unfavorable for the early humans, because when it comes to size, they stood very little chance against such predators. But that would be undermining their intelligence. Over time, early humans might have developed tools and strategies to fight back against the Nyandong tiger, forcing the tigers back to the open woodlands, and allowing early humans to establish a foothold in the region. The open woodlands of Sunderland in the Pleistocene epoch had numerous scattered trees and grasslands, which provided good visibility for stalking prey and offered a diverse array of herbivores, including many large species. However, hunting larger herbivores may not have been that successful despite the Nyandong's enormous size. Stegodons, for instance, were massive proboscideans closely related to elephants, with some species reaching immense sizes. Even smaller species of stegodons would have dwarfed the Gondong tiger. Stegodon donsky, for instance, is estimated to have weighed around 12.7 tons. When the first Smilodon remains were unearthed, paleontologists didn't immediately recognize them as belonging to a cat. In fact, their initial guess was way off the mark. Based on some isolated cheek teeth that bore an uncanny resemblance to those of modern hyenas, they dubbed this new find Hyena neoga. However, within a couple of years, a tsunami of new fossils came to light. Suddenly, scientists weren't just looking at a few teeth, but a veritable jigsaw puzzle of prehistoric proportions. Foot bones, skull fragments, and those iconic canines, which, by the way, seemed almost comically oversized for any mouth, painted a very different picture. As the pieces fell into place, it became clear that this was no hyena. Instead, they were dealing with a completely new genus of felid, one that was not only massive in size, but also built like a prehistoric tank. This feline was far more robust than any modern cat, a true heavyweight champion of the Ice Age. In light of this revelation, a new name was in order. Thus, Smilodon populator was born. Smilodon, meaning knife tooth, and populator, roughly translating to the destroyer, or he who brings devastation. It's a fitting moniker for a predator that redefined what it meant to be lethal. With its new identity established, the scientific community dove headfirst into unraveling the Smilodon's family tree. This quest for understanding continues to this day, with researchers currently placing our knife-toothed friend in the extinct subfamily Machairodontini, This subfamily is home to most of what we colloquially call saber-toothed tigers, though saber-toothed cats is more accurate since these ancient felines aren't closely related to modern tigers, or any living cats for that matter. In fact, their closest living relatives might be members of the felinae subfamily, which includes our domestic kitties. Within the Machaerodontinae, Smilodon found itself in an even more exclusive club, the Smilodontini, or as some paleontologists like to call them, the dirk-toothed cats. This group is pretty exclusive, with only 5 known genera calling it home. But what Smilodontini lacks in diversity, it makes up for in star power thanks to Smilodon. As research progressed, scientists discovered that Smilodon wasn't a lone standout. It was more like a prehistoric trio with 3 distinct members, each bringing something unique to the table: S. gracilis, S. fatalis, and S. populator. Now, if you found yourself face to face with any of these species, you probably wouldn't be too concerned with which one was about to turn you into lunch. But they did have their differences. First up, we have S. gracilis, the elder statesman of the group. This OG appeared in North America about 2.5 million years ago, descending from an even older genus called Meganterion. To put it in perspective, Smilodon's canines could grow up to 8 inches, or 20 centimeters long. That's longer than many modern kitchen knives. They were precision instruments of prehistoric destruction, shaped like deadly daggers with sharp points and smooth, narrow sides. Here's where things get interesting. You'd expect a predator with teeth like that to have a powerful bite to match, but studies have shown that Smilodon's bite was relatively weak. Only about 1,000 newtons, which is 4 times weaker than a modern lion's. So how did it kill? That's been a subject of much debate among paleontologists. One popular theory suggests that Smilodon was the original ambush predator. I picture it hidden in dense vegetation, waiting for the perfect moment. Then, with a powerful leap, it pounces on its unsuspecting prey. Using those muscular forelimbs and grappling hook claws, it pins down its victim. With precision, it sinks its saber teeth into the prey's soft underbelly, causing massive internal damage and blood loss. But not everyone buys this gut-stabbing hypothesis. Many researchers favor a different but equally grim scenario. They propose that Smilodon used its powerful build to quickly overpower its prey, then delivered a precise lethal bite to the throat. This would have caused severe blood loss and suffocation. A quick, if not particularly pleasant end for its unfortunate victims. In South America, Smilodon's targets were equally impressive and diverse, including creatures like Toxodon, Litopterna, various species of Glyptodont, along with more familiar animals such as horses and camelids. Some evidence even suggests that Smilodon occasionally went after caimans, cementing its status as a top predator. We know what Smilodon ate thanks to skeletal evidence such as tooth marks on bones, or Smilodon remains found alongside those of their prey, providing vital clues about its diet. One big question that's still hotly debated in paleontology circles is whether Smilodon was a lone hunter or a team player. This isn't just academic curiosity. Knowing whether Smilodon hunted in packs could tell us a lot about its social structure and what kind of prey it typically targeted. One of the strongest pieces of evidence supporting the idea that Smilodons lived socially comes from the La Brea tar pits in California. These California tar pits are a gold mine for paleontologists, preserving countless Ice Age animals that got stuck in the sticky asphalt. But most of the bones found in La Brea aren't from herbivores that got trapped, but from predators that got stuck trying to eat the trapped herbivores. Smilodon fossils are the second most common find in these pits, with over 166,000 bones attributed to it. This high number has led some scientists to suggest that Smilodon might have been a social animal. The reasoning goes like this. In modern cat species, the more social ones tend to be more responsive to distress calls. So, if one Smilodon got stuck, it might have called for help, attracting other members of its group who then also got stuck. It's a grim thought, but it could explain why we find so many Smilodon remains in one place. Another fascinating clue pointing to Smilodon's possible social behavior is surprisingly touching, though in a prehistoric, slightly grim sense. Some Smilodon fossils show signs of severe injuries or disabilities that would have made hunting nearly impossible. Yet, these individuals survived well into adulthood. This has led some paleontologists to propose what they call pseudo-healthcare among Smilodons. The idea is that these injured animals— I've always found it touching, the idea that even saber-toothed cats cared for their own. There's a Smilon fossil that shows signs of hip dysplasia from a young age. Yet this cat survived to adulthood. How could it have hunted alone? It paints a heartwarming picture of Smilon families looking after each other. Of course, not everyone agrees on this vision of a Smilon social club. Some researchers point to remains found outside predator traps, remains that are often isolated. This suggests a more solitary lifestyle, more like many modern big cats. Regardless, one thing's for: the Smilon was at the top of the food chain. But it wasn't alone. The relationship was likely tense. We were competing for the same food sources, and by the time humans arrived, only the larger Espopulator and Espatulus remained. Given that Meganterion, the possible predecessor of Smilodon, was known to occasionally prey on Homo erectus, it's not a stretch to imagine that Smilodon might have considered early humans as potential prey too. I find myself thinking often about the petroglyph discovered in 2021. A group of humans observing a Smilodon from a safe distance. It offers a tantalizing glimpse into a world where we shared the landscape with those magnificent, terrifying creatures. But as we know, that coexistence didn't last. Around 10,000 years ago, Smilodon disappeared. It was around the same time that humans in some parts of the world were discovering agriculture. The extinction of Smilodon still fuels debate among paleontologists. Some believe humans played a role, either through competition or by changing habitats with practices like controlled burns. Others aren't so. The more widely accepted theory points to the broader Quaternary extinction event. This period of significant climate change led to the disappearance of many large animal species in North and South America. As the megafauna that Smilodon relied on began to die out, the saber-toothed predator found itself in an increasingly precarious position. It's a cruel twist of fate, really. The very adaptations that made Smilodon such a successful hunter of large prey became a liability. Specialized to take down giants, it struggled to adapt to a world where those giants were disappearing. It was, in essence, too good at what it did. When the world changed, it couldn't change with it. The extinction of Smilodon marked not just the end of a species, but the end of an era. It was the last of the saber-toothed cats, not just in the Americas, but worldwide. A lineage that had dominated the planet for over 20 million years came to an end. Its legacy, however, still resonates in museum exhibits, in our imaginations, and as a reminder of the fragile balance between species and their environments. As we face our own period of rapid change, the lesson of Smilodon is clear. Survival requires adaptation. Most apex predators face a fundamental limitation. They're trapped in one environment. Lions rule the savanna, but are helpless in water. Great whites dominate the ocean, but can't set a fin on land. Even T-Rex, for all its might, was confined to dry ground, forced to watch as prey slipped into rivers and lakes beyond its reach. For over a century, paleontologists assumed the greatest hunters were strictly terrestrial. Then, one discovery shattered that belief overnight. Spinosaurus aegyptiacus. Longer than a bus, armed with the skull of a crocodile and the body of a streamlined aquatic hunter. This was no ordinary killer. This was the nightmare that redefined what it meant to be an apex predator. A monster that could rival, and in many ways surpass, even T-Rex itself. The first thing that strikes you about Spinosaurus isn't its length. Though at 50 to 59 feet, it dwarfs even the largest T-Rex specimens. It's not even the massive sail rising from its back, like some prehistoric fin. No. What truly unsettles you is how perfectly wrong everything about this creature appears. Yet, how devastatingly effective each bizarre feature proved to be. Take that skull. A narrow, elongated nightmare stretching nearly 6 feet long. If you've ever stared into the eyes of a large crocodile, you understand the primal fear that comes from seeing a predator perfectly designed for aquatic ambush. Now, imagine that same sinister profile scaled up to dwarf any modern crocodilian, mounted on a body that could rear up 20 feet into the air. The skull alone weighed as much as a small car, yet it cut through water with the efficiency of a torpedo. Those jaws housed over 60 interlocking teeth, each one a curved, needle-sharp instrument of death designed for one purpose: gripping slippery, struggling prey underwater. Unlike the bone-crushing teeth of T-Rex, built for delivering massive bite forces to terrestrial victims, Spinosaurus's teeth were fishing spears made of enamel. Once those jaws clamped down on a 15-foot sawfish or massive lungfish, escape became physically impossible. But the skull was just the beginning of this creature's aquatic arsenal. Where other theropods developed powerful legs for running down prey across land, Spinosaurus rewired its body for a different kill zone. Its toes were webbed, its legs positioned differently, its entire lower body redesigned for propulsion through water rather than speed across terrain. For anything living in those rivers, the nightmare was the same. The faint ripple at the surface, the sudden silence, and then the 7-ton shadow sliding in after you. And while most large theropods had relatively small forelimbs, Spinosaurus possessed powerful, elongated arms ending in massive claws. These weren't vestigial appendages. They were additional weapons, perfectly positioned for grabbing prey, maintaining balance in water, or delivering killing blows. The creature could literally embrace its victims to death. And then there's the sail, rising up to 7 feet above its spine. This massive dorsal fin dominated Spinosaurus's silhouette, like the warning flag of death itself. Scientists debate its exact function: thermoregulation, display, fat storage for surviving dry seasons. But its psychological impact is undeniable. Picture this nightmare rising from murky water. First, the elongated snout breaking the surface. Then, those cold reptilian eyes. And finally, that towering sail cutting through the air, like the dorsal fin of some impossible shark. Imagine being a large fish in the rivers of Cretaceous Africa. You've spent your entire lineage adapting to recognize danger. The shadow of a pterosaur overhead, the ripples of an approaching crocodile, the subtle current shifts that signal a predator nearby. Every instinct is tuned to read these watery warning signs, sharpened by countless generations of survival. But none of that mattered when Spinosaurus arrived. That massive sail on its back wasn't just for show. It served another, more practical purpose, one that would have terrified any creature unlucky enough to encounter Spinosaurus in shallow water. When the beast needed to move through areas where full swimming wasn't possible, that dorsal structure acted like the keel of a boat, providing stability and control, even in water too shallow for other large predators to navigate effectively. Spinosaurus remained a perfectly balanced killing machine. Even at 7 to 9 tons, it possessed the mass to overpower virtually any prey, yet remained streamlined enough to move through water with deadly grace. Modern great white sharks inspire fear because they embody millions of years of mastery in aquatic predation. But Spinosaurus had even longer to sharpen the same deadly craft, only with added intelligence, versatility, and sheer size that dwarfs any marine predator alive today. The result wasn't just a hunter of rivers and lakes. It was a 7-ton monster that transformed every waterway it entered into its personal killing field. On land, giants like Carcharodontosaurus patrolled the inland areas, while Spinosaurus dominated the waterways, and Sarasuchus, the 40-foot supercroc, competed directly with it for aquatic hunting grounds. Mid-sized hunters such as Rugops cleaned up Spinosaurus leftovers, while swift predators like Deltadroius and Behemoth used speed and specialized tactics to carve out their place. Herbivores somehow survived this gauntlet: Ouranosaurus, Rebbachisaurus, and the colossal Paralititan. The waters themselves were far from safe, filled with monstrous prey like Entroprist, Morsonia, Chelanths, Lepidotes, and lungfish. Every species in this ecosystem lived in constant tension with Spinosaurus's dominance. Land predators maintained uneasy truces. Herbivores relied on elaborate survival tactics just to drink, and aquatic prey developed increasingly tough defenses. The last Spinosaurus died approximately 94 million years ago. But the questions this creature raises about predation, dominance, and the very limits of survival continue to ripple through scientific understanding. When we think of prehistoric apex predators, our minds often drift to the iconic Tyrannosaurus rex, or the fearsome megalodon. Yet, lurking in North America's ancient past was a predator so extraordinary it could make today's largest wolves look like lapdogs. Today's grey wolf may hold the crown as the largest living canid, reaching weights at 65 kg 143 lbd. But rewind to the Miocene epoch 20 to 5 million years ago, and the game changes. A new apex predator emerges. Meet Epicon, a colossal predator so fearsome it could rival a lioness in size, and had jaws powerful enough to outmatch a grizzly bear. In simpler terms, this was a dog that could eat a lion. Its name says it all. Epicyon, meaning more than a dog. Because calling it just a dog doesn't do it justice. The story of Epicon's discovery represents one of paleontology's most intriguing progressions, from misidentification to revelation. Over 160 years ago, in the fossil-rich sediments of Nebraska, scientists unearthed the first fragments of what would later be recognized as the largest canid species ever to walk the earth. The initial discovery consisted of a fragmented lower jaw. While obviously from a large carnivore, it provided only hints of the creature's true nature. The jaw's wolf-like characteristics led early paleontologists to classify it as a subgenus of Canis, the genus that includes modern wolves, coyotes, and jackals. This classification seemed logical at the time, given the limited fossil evidence. However, as more complete specimens emerged from North American fossil beds throughout the following decades, a much more complex picture began to emerge. The discovery of complete skulls proved particularly revolutionary. These specimens revealed that while certain features resembled those of wolves, others were startlingly different. The skull was unlike anything I had ever seen. It had enlarged premolars and a cranial structure that looked more like a lion or hyena than any dog I knew. I remember thinking, what exactly was this creature? The answer, as so often happens, lay in the details. Those specialized premolars and that robust jaw, they pointed to the Paraphysornis subfamily. This group, though one of the most successful branches of the canid family, remains relatively unknown. Imagine 66 known species, all with powerful teeth, short, deep jaws, and a fifth toe, a feature lost in many modern dogs. For over 15 million years, they dominated North America. Some were fox-sized, others rivaled modern grey wolves. And then there was Epicyon, the ultimate bone-crushing dog. Its name literally means more than a dog. Recent studies of modern canids have helped us understand where Epicyon fits in. The Paraphysornis, it seems, were a highly specialized branch, taking a unique evolutionary path, diverging from the lineage that led to modern wolves and dogs. This helps explain Epicyon's unusual features, and perhaps its eventual fate. Within the Epicyon genus, 3 distinct species emerged: E. savus, E. haydeni, and E. elodontoides, each filling a different ecological niche. The smaller species, Savus and Elodontoides, were more gracile, built for agility and speed. Even they, though, would have weighed twice as much as a modern German shepherd. But it was Epicyon haydeni that truly pushed the boundaries. Adults reached lengths of almost 8 feet, rivaling a grizzly bear, and stood nearly 3 feet tall at the shoulder, like a wild deer. They weighed between 220 and 276 pounds, heavier than modern leopards, comparable to large jaguars. Some individuals reached weights of around 370 pounds, matching medium-sized male lions. That would make them the heaviest canids ever to exist. Size wasn't everything, though. Epicion's bite was its most remarkable feature. Biomechanical studies suggest it had one of the most powerful biting mechanisms of any mammalian carnivore. Enlarged premolars and strategically positioned canine teeth closer to the jaw joint than in modern canids created a highly efficient biting apparatus. Some analyses suggest its bite force exceeded 16,000 newtons, comparable to a large American alligator. The closer placement of the canines to the jaw joint created a more efficient lever system, concentrating enormous force at the tooth tips. It could pierce thick hide, flesh, even bone. Microscopic analysis of wear patterns on preserved teeth confirms this. The patterns are consistent with both flesh slicing and bone crushing, suggesting a predator that could efficiently process every part of its prey. The Miocene epoch was marked by significant climate fluctuations, with periods of both warming and cooling, and shifts between wet and dry conditions. When prey was scarce, being able to fully use every part of a carcass, including the bones, would have been a crucial survival advantage. The success of Epicion is clear from how widely it was distributed across North America during the Miocene. Fossil remains have been found in more than 10 different US states and parts of southern Canada, which shows it could adapt to different environments. Recent paleo-environmental studies have shown that these ancient predators thrived in a range of habitats, from woodlands and savannas to grasslands and wetlands. What I find particularly interesting are the recent discoveries of Epicion remains in cave systems and edge environments, where different habitat types meet. These findings suggest that Epicion wasn't just adaptable, but possibly strategic in its habitat selection, preferring areas that offered both hunting opportunities and shelter. Their ability to process a variety of foods likely contributed to this ecological flexibility. While they were mainly carnivorous, the structure of their teeth suggests they could also process tough plant material when necessary. This dietary flexibility, combined with their bone-crushing abilities, would have allowed them to survive in a wide range of environments and through various seasonal changes. The ultimate disappearance of Epicion from the fossil record has long intrigued paleontologists. Early theories suggested that competition from newly arriving big cats led to their extinction. But this idea has largely been dismissed because many of the large cats that would have competed with Epicion, like the famous Smilodon, didn't appear in North America until millions of years after Epicion disappeared. Current evidence points to climate change as the main reason for Epicion's extinction. The late Miocene saw significant global cooling and increased aridity, which led to fundamental changes in North American ecosystems. Recent paleobotanical studies indicate a shift from mixed woodland savanna environments to more open grasslands. This transformation would have affected not only the types of prey available, but also hunting strategies. Epicion's specialized adaptations, its heavy build, bone-crushing teeth, and relatively short legs, may have become a disadvantage as prey species became faster and more adapted to open environments, unlike their more generalized relatives, which gave rise to modern wolves and other canids. Epicion's extreme specializations may have limited its ability to cope with these changing conditions. It's funny, isn't it? In the dying days of the Cretaceous period, with colossal predators like Tyrannosaurus rex dominating, creatures like Triceratops and Hadrosaurs often bear the scars of T-Rex attacks. But amid this world of relentless aggression, the fossils of one creature remain curiously unmarked by such ferocious battles. It wasn't the tallest, fastest, or most fearsome predator, but with a body armored like a tank and a tail capable of shattering bones, this creature defied the rules of survival and made even the mighty T-Rex think twice. This was Ankylosaurus, nature's ultimate fortress, a living testament to the art of defense in an age of unyielding predators. The story of this extraordinary creature began in the early 20th century, when paleontologists working in Montana's Hell Creek Formation uncovered a collection of unusual fossils. These weren't the typical bones they were used to finding. Instead, they discovered I'll never forget the first time I saw the Dion of Ankylosaurus magnaventris, a fused lizard with a great belly. It read like something out of a dream. But this was real, a discovery that rewrote our understanding of dinosaur defense. The holotype specimen presented such a unique combination of features that it demanded its own taxonomic family. It opened a window into the intricate design of one of nature's most formidable creatures. Back in 1906, Barnum Brown, a renowned paleontologist from the American Museum of Natural History, led an expedition through Montana's Hell Creek Formation. Among the layers of Cretaceous sediment, Brown unearthed an assortment of fossils that, at first glance, perplexed him. These weren't the slender bones of theropods or the broad frills of ceratopsians. Instead, he uncovered fragments of bony plates, uniquely shaped teeth, and vertebrae that hinted at a heavily armored animal. Early interpretations were cautious. Brown initially speculated that the bones might belong to a previously unknown type of armored dinosaur. Over time, further excavations in Canada and the western United States revealed more specimens, each shedding light on the creature's physical characteristics. The painstaking process of piecing together its skeletal framework was akin to assembling a prehistoric jigsaw puzzle, with every discovery adding a layer of complexity to its story. What made Ankylosaurus magnaventris stand out was not only its robust anatomy, but also its ecological implications. Fossils of Ankylosaurus were found in association with remains of plants, indicating the lush environments it inhabited. Over the decades, advances in paleontological techniques, including CT scanning and isotope analysis, have allowed scientists to reconstruct its appearance and understand its lifestyle in remarkable detail. From the armored plates that defined its body to the distinctive club at the end of its tail, Ankylosaurus stood as a creature that epitomized nature's ingenuity. This discovery didn't just represent a new species. It became the cornerstone of an entirely new group of dinosaurs, the Ankylosauria. These animals, belonging to the larger clade Ornithischia, were characterized by their extensive armor plating and herbivorous lifestyle. Within this group, Ankylosaurus belonged to a more specialized family, the Ankylosaurids, distinguished by their massive triangular skulls, stocky builds, and elaborate defensive features. But among all its relatives, Ankylosaurus held a special distinction. It was the largest of its kind ever discovered, with adults reaching lengths between 5.4 to 10 meters, or 17 to 33 feet, and standing about 1.7 meters at the hip. More impressively, these titans weighed between 5 and 8 tons, surpassing even the famously robust Triceratops in mass, and rivaling the earlier aquatic predator Spinosaurus. One might wonder how a relatively low-slung animal could pack such impressive weight into its frame. The answer lies in its extraordinary construction. Imagine a biological tank, meticulously designed for strength and survival. The Ankylosaurus's skeleton was built unlike any other dinosaur, with dense, compressed bones forming a sturdy foundation for what would become one of nature's most sophisticated armor systems. Recent studies of its bone structure have revealed something fascinating. The bones themselves were uniquely reinforced with internal struts and buttresses, similar to the architectural principles used in modern building construction. Unlike other armored dinosaurs that had solid, thick plates, the Ankylosaurus possessed something more sophisticated: osteoderms with hollow undersides. This seemingly counterintuitive design actually represented a remarkable feat of natural engineering. The hollow structure created a dome-like formation that distributed impact forces more effectively than solid plates would have, similar to how modern motorcycle helmets use their curved design to protect riders. This adaptation made the armor particularly effective. The tail club of the Ankylosaurus wasn't just a bony growth. It was a precisely engineered weapon, one of nature's most effective deterrents against predation. Recent CT scans of those tail club fossils have revealed an intricate internal structure, optimized for both strength and swing speed. I find myself wondering how many predators learned the hard way not to mess with this armored tank. Beneath the armored plates of the Ankylosaurus lay a network of collagen fibers that puts modern protective materials to shame. These fibers, significantly thicker than those found in modern armored animals like crocodiles and armadillos, created a natural composite material similar to modern fiber-reinforced plastics. Biomechanical studies have shown that this combination of hard plates and flexible fibers could absorb and dissipate energy from impacts in ways that purely rigid armor couldn't match. In fact, when subjected to simulated impact tests, reconstructions of Ankylosaurus armor proved capable of withstanding forces that would have seriously injured or killed most other dinosaurs. It was an effective defense against the crushing bite force of predators like T-Rex, whose hunting strategy relied heavily on delivering powerful bone-crushing bites. The club itself was composed of two large osteoderms at its core, complemented by smaller ones at the tip and along the midline, all supported by a framework of highly modified vertebrae specifically adapted to handle the stresses of high-speed impacts. The mements are staggering. Specimens show the club could reach 57 cm or 22.5 inches in width and weighed approximately 23 kilon, or 50 pounds. But these numbers only tell part of the story. The real marvel was in the biomechanics. Advanced computer modeling has shown that large individuals could generate impact forces exceeding 20,000 newtons, and, even more remarkably, could achieve swing impulses of up to 4,800 newtons per second. To put this in perspective, While a professional baseball player generates about 13 newtons per second in their swing, the Ankylosaurus's tail strike was 370 times more powerful. Recent studies using finite element analysis have even suggested that the impact force could have been focused on an area as small as a few square centimeters, multiplying its bone-crushing potential. The behavior and lifestyle of Ankylosaurus were as unique as its anatomy. While much of its life remains a mystery, fossil evidence offers glimpses into its daily routines and survival strategies. Juvenile Ankylosaurus specimens, for example, lacked the fully developed armor and tail clubs seen in adults. This vulnerability likely necessitated group behavior during the early stages of life. Trackway fossils suggest juveniles may have formed protective herds, with larger individuals shielding the more vulnerable young in the center, a defensive strategy reminiscent of modern musk oxen. As they matured, Ankylosaurus individuals underwent significant lifestyle changes. Adults appear to have been predominantly solitary, a conclusion supported by the rarity of adult specimens found in groups. Their solitary behavior was likely a reflection of their formidable defenses, which allowed them to traverse their environments without fear of predation. Solitary adults might have roamed large territories, primarily in search of food and suitable habitat, avoiding direct competition with other herbivores. Some paleontologists have speculated that Ankylosaurus might have used its tail club for intraspecific communication or dominance disputes. This theory is supported by observations of similar behaviors in modern animals with physical weaponry, such as bighorn sheep or rhinoceroses. The display of their tail clubs, combined with body size and posturing, could have deterred rivals without escalating into physical conflict. However, the evidence remains inconclusive, and further fossil discoveries may provide clarity on this aspect of their behavior. Ankylosaurus thrived in the rich and dynamic ecosystems of late Cretaceous North America, particularly in regions that would later become known as the Hell Creek Formation. This area was a mosaic of environments ranging from subtropical forests to open floodplains teeming with diverse flora and fauna. Fossilized plant remains suggest Ankylosaurus inhabited regions with abundant low-growing vegetation, which suited its low-slung, ground-grazing body. The climate of the late Cretaceous was warmer and more humid than today, which supported lush forests dominated by conifers, cycads, and ferns. Ankylosaurus likely played a role in shaping this ecosystem, though not as extensively as herding dinosaurs like hadrosaurs. Instead, its selective feeding habits might have influenced plant growth patterns in localized areas. The association of Ankylosaurus fossils with specific types of vegetation has led researchers to hypothesize that they may have helped disperse seeds, inadvertently promoting plant diversity. Seasonal changes would have impacted the behavior of Ankylosaurus. Fossil evidence indicates that some regions experienced dry and wet seasons, influencing the availability of food resources. Ankylosaurus may have adapted by modifying its diet or undertaking small-scale migrations to follow vegetation growth. The robust construction of its body, coupled with its ability to consume tough plant material, would have allowed it to survive in less than ideal conditions. The coexistence of Ankylosaurus with large herbivores like Triceratops and Edmontosaurus, as well as apex predators like Tyrannosaurus rex, paints a vivid picture of its ecological niche. While Ankylosaurus was not the most numerous dinosaur in its ecosystem, its defensive adaptations end its survival alongside fierce competition. Its presence in these environments exemplifies. I sometimes think about the food web as a finely balanced machine, where even the most specialized roles allow so many diverse species to coexist. It's fascinating to consider how each creature finds its niche. Take the Ankylosaurus, for example. It was primarily herbivorous, with adaptations that made it incredibly effective at processing tough, fibrous vegetation. Its broad, low-slung muzzle and simple ridged teeth were ideal for stripping and grinding low-growing plants like ferns, cycads, and horsetails. Unlike some herbivorous dinosaurs with elaborate dental structures, Ankylosaurus relied on its powerful jaw muscles to break down plant material. Recent studies on Ankylosaurus teeth have revealed wear patterns suggesting a surprising degree of dietary flexibility. While its primary diet was vegetation, it may have occasionally consumed protein-rich fungi or small invertebrates, inadvertently gathered while feeding. This opportunistic behavior isn't uncommon. Modern herbivores like tortoises and iguanas sometimes supplement their diets with protein. The digestive system of Ankylosaurus likely included a large, complex gut capable of fermenting plant material. This would have been necessary to extract sufficient nutrients from its fibrous diet. Fossilized coprolites attributed to similar herbivorous species suggest the presence of symbiotic gut bacteria, which would have played a crucial role in breaking down cellulose. This process would have produced energy-rich byproducts, allowing Ankylosaurus to maintain its massive body size. I find it interesting that Ankylosaurus's broad midsection may have been a specialized design to house its extensive digestive system. The large gut volume would have provided ample space for fermentation and nutrient absorption, ensuring the animal could survive on a diet of relatively low-calorie plants. This adaptation, combined with its sturdy build and slow metabolism, likely made Ankylosaurus an efficient grazer, well suited to its environment. Its sensory capabilities were as finely tuned as its defensive adaptations. The most remarkable sensory feature was its highly developed sense of smell, vital for locating food, avoiding predators, and possibly detecting mates. One particularly intriguing hypothesis is that Ankylosaurus may have used its sensory abilities in conjunction with its defensive adaptations. For instance, its acute sense of smell and hearing could have allowed it to detect a predator's approach early enough to position itself defensively, presenting its armored back and tail club to the threat. These advanced sensory capabilities underscore the Ankylosaurus as a highly specialized organism, perfectly equipped to navigate its dangerous environment. The reign of Ankylosaurus came to an end, along with that of other non-avian dinosaurs during the KT extinction event approximately 66 million years ago. However, its legacy lives on in our understanding of natural design and defense mechanisms. The Cretaceous period was an era of titans. This epoch produced not only the largest terrestrial predator, but also the largest land animal ever known. a true monster mash of epic proportions. While dinosaurs dominated, other species also reached massive sizes, including flying reptiles and marine lizards. Around 82 million years ago in North America, the world witnessed the emergence of Deinosuchus, the largest crocodilian in Earth's history. This colossal crocodilian, whose name translates to terrible crocodile, was discovered in the 1850s when large, distinctive teeth were unearthed in North Carolina. Initially, these teeth were mistaken for those of a pliosaur, a type of marine reptile, leading to considerable confusion among paleontologists. However, they quickly realized that this creature was massive and imposing. The sheer size and unique characteristics of the teeth did not align with known marine reptiles, prompting a deeper investigation. The journey to accurately identify this gigantic predator was significantly advanced by Dr. Joseph Leidy, a leading paleontologist of the 19th century. His meticulous examination and publications played a pivotal role in re-evaluating these remains. Leidy's research corrected the initial misclassification, revealing that the teeth belonged to an entirely different kind of prehistoric creature. The newly proposed classification reflected the immense size and formidable presence of this crocodilian, which was aptly named Deinosuchus hatcheri in honor of John Bell Hatcher, a distinguished paleontologist. It's almost unbelievable to think that crocodilians once existed that could outweigh most dinosaurs, even the mighty Tyrannosaurus rex. That image has stayed with me since I first encountered it. These weren't just big, they were colossal. Initially, we thought adult Deinosuchus might have reached almost 50 feet in length, weighing over 10 tons. While those early estimates were a bit exaggerated, they weren't too far off. What's fascinating is that, unlike some species whose size gets downsized over time, Deinosuchus has held on to its reputation as a true giant. There are 3 recognized species: Deinosuchus hatcheri, Deinosuchus rugosus, and Deinosuchus riograndensis. The hatchery, found in North Carolina, was among the first identified, giving us crucial insights into the genus. The rugosus, mainly from Montana, had a more robust build, maybe an adaptation to different prey or environments. But the riograndensis, discovered in Texas, grew even larger. The more plentiful and better preserved remains of the riograndensis have really helped us understand the lives of these giants. We think the average adult Deinosuchus measured between 26 and 33 feet long and weighed between 2.5 and 5 tons, more than twice the size of a male hippo, and some grew even larger. Despite those initial inflated estimates, the reality of Deinosuchus's size is still incredibly impressive. The riograndensis species really stands out. Studies suggest the largest individuals could reach up to 39 feet and weigh around 8.5 tons. That makes them not only the largest crocodilians ever, but heavier than most dinosaurs, except for Tyrannosaurus rex. Paleontologist Thomas Lehmann's work on the Texas fossils has given us some fascinating insights. He found growth rings in their osteoderms, like tree rings, which told us about their age and growth rates. Some of the largest riograndensis showed rapid growth spurts as juveniles, followed by slower growth into adulthood. It really underscores how environmental factors like food and climate affected their size. Deinosuchus, with its brain case, had a striking resemblance to modern alligators, with a similar body and snout. But beyond that, Deinosuchus was unique, with a skull shape unlike any other crocodilian, living or extinct. The skull was huge, up to 5.6 feet long, comparable to an adult Spinosaurus. Despite its size, studies suggest Deinosuchus's bite force was surprisingly modest. One study reported about 18,000 newtons, enough to crush bones, but relatively weak for its size, especially compared to the smaller saltwater crocodile, which exerts 16,500 newtons. Fossil examinations show the skull was not only massive, but highly specialized. The teeth were arranged in a way that suited its predatory lifestyle: conical, sharp front teeth for grasping prey, and blunt, robust rear teeth for crushing bones. This allowed Deinosuchus to tackle everything from large dinosaurs to hard-shelled turtles. The bite force has been debated quite a bit. Initial research suggested around 18,000 newtons, based on the skull's size, but later studies proposed a bite force exceeding 100,000 newtons, almost double that of Tyrannosaurus rex. It's a big discrepancy, and the paleontological community is still working it out. Dr. Greg Erickson, who led one of the key studies, used biomechanical modeling to simulate Deinosuchus's bite. His team found that the robust construction of the skull and teeth could support such a powerful bite. With exceptionally robust teeth designed for high forces, some specifically for crushing bones, it was well equipped to exert tremendous press. The latest evidence leans toward the higher end of the estimated range, suggesting Deinosuchus really did have one of the most powerful bites of any known predator. This aligns with the physical characteristics of its skull and teeth, suggesting it could generate extreme biting forces, making it one of the most formidable crocodile forms ever to have existed. The formidable bite force, along with its durable and sizable teeth, about the size of a banana, points to its role as a dominant predator. I've often wondered about the ancient world and the creatures that dominated it. Imagine a crocodile, but not just any crocodile, one that dwarfed even the largest of today's reptiles. A creature so massive that it posed a threat even to dinosaurs. That was Deinosuchus. Fossilized tail vertebrae from duck-billed dinosaurs, bearing bite marks consistent with Deinosuchus, give us clear indications of its feeding habits. It seems hadrosaurs like Gryosaurus and Chasmosaurus were particularly at risk. Its impressive size and strength made it a potential threat to other dinosaurs, including Ankylosaurus and Hadrosaurus. Even large theropods like Appalachiosaurus weren't immune. Certain bite marks on their bones have been attributed to Deinosuchus. It likely influenced the size and distribution of other theropods in its eastern habitat, becoming the apex predator. Coprolite analysis has revealed direct evidence of its diet. These fossilized feces contain fragments of dinosaur bones, fish scales, and turtle shells, providing a snapshot of its varied meals. Dr. Karen Chin, a specialist in coprolite studies, emphasizes the importance of these findings, noting that the diverse prey items highlight its opportunistic feeding behavior. It seems this ancient predator consumed a wide range of animals, from large herbivorous dinosaurs to smaller aquatic creatures. Deinosuchus is thought to have used ambush tactics to capture its prey, leveraging its massive size and crushing bite to inflict fatal injuries. Like modern crocodiles, this giant predator likely employed a death roll maneuver to enhance its hunting efficiency, grabbing prey and then rapidly rotating to incapacitate and dismember it. Reconstructing these hunting methods involves analyzing fossil evidence and comparing it with the behavior of modern crocodilians. The robust anatomical features of Deinosuchus, including strong neck muscles and a sturdy body, support this hypothesis, making it a highly effective predator in its ancient ecosystem. Growth rings on its osteoderms show that Deinosuchus experienced a slow growth rate, taking around 35 years to reach full size. But even juvenile Deinosuchus were formidable predators, sporting considerable size and powerful bites. Adding to their fearsome nature, they were equipped with large, thick osteoderms, bony plates that provided substantial protection against predators and environmental hazards. These osteoderms not only served as armor, but also supported the animal's massive body, increasing its load-bearing capacity and enabling efficient movement on land despite its size. Deinosuchus was a highly successful predator, evidenced by its extensive range, with remains found throughout the United States and northern Mexico. During its prime, the American continent was divided by the Western Interior Seaway, a shallow sea, and Deinosuchus thrived on both sides of it. It inhabited diverse environments, including estuaries, freshwater lakes, rivers, and possibly even deeper marine waters, although some believe that the marine remains could have been displaced post-mortem. The adaptability of Deinosuchus is showcased by its preference for estuaries, coastal bodies of brackish water with river or stream inlets. However, it also thrived in freshwater lakes and rivers, and was potentially present in marine environments. Its strong limbs and tail allowed it to navigate both aquatic and terrestrial settings, tolerating varying salinity levels, which further demonstrates its ecological flexibility. If Deinosuchus indeed ventured into deeper waters, it might have encountered other giant predators like Tiosaurus, one of the largest mosasaurs. This interaction could suggest a complex predator-prey dynamic within its ecosystem, influencing the behavior and distribution of various species. Deinosuchus lived alongside a vast array of dinosaurs and other prehistoric creatures. It coexisted with herbivorous dinosaurs like Anodinosaurus, Griosaurus, Cosmoceratops, and Eutroceratops, among many others. Bite marks on the bones of hadrosaurs and other dinosaurs provide clear evidence of its predatory behavior. Its presence likely impacted the distribution and behavior of these animals, asserting itself as an apex predator in its habitat. Despite its dominance, Deinosuchus vanished from the fossil record around 73 million years ago. The reasons for its extinction remain unclear. Though climate changes, sea level fluctuations, and competition with emerging predators are potential factors, its extinction marked the end of an era. But the fossil remains of Deinosuchus continue to provide valuable insights into the life and ecosystems of the late Cretaceous period. Thinking about apex predators always fascinates me. In the world of big cats, the tiger, lion, and jaguar have always fought for supremacy, each vying to be the ultimate predator. But there's one ancient beast that towers above them all, the American lion. This was no ordinary feline. It was the largest to ever walk the earth. Imagine a creature so massive that some individuals weighed as much as an adult brown bear, easily dwarfing today's biggest lions. This isn't just another big cat. It's a legendary predator that dominated its world like no other, leaving modern felines in the dust. The story of this magnificent creature's discovery begins in the humid lands of Mississippi during the early 1800s. When paleontologists first unearthed fragments of its skull, they initially believed they had found remains of an unusually large domestic cat, placing it in the genus Felis. This classification, however, would prove to be just the first chapter in a much longer story of scientific discovery and reclassification. As more specimens emerged from the Earth, scientists quickly realized they were dealing with something far more impressive: the sheer size and distinctive features. The American lion. The name conjures images of a creature both familiar and alien. I find myself wondering, what if I were to come face to face with a beast 25% larger than today's African lions? Modern science has reshaped our understanding of this prehistoric life. The discovery of Blue Babe, a remarkably preserved steppe bison in Alaska, bears the unmistakable marks of an American lion attack. Deep claw wounds and distinctive bite patterns that match the predator's dentition. Even more telling are the fossils found at sites like Natural Trap Cave in Wyoming, where researchers have uncovered numerous prey species bearing the characteristic damage patterns of American lion predation. What truly set American lions apart from their contemporary rivals wasn't just their size. It was their exceptional adaptability and territorial dominance. Recent studies of fossil deposits across North America have revealed fascinating insights into their social structure and hunting territories. Unlike modern African lions that typically control territories of 100 to 200 km, evidence suggests that American lions commanded vastly larger ranges, some extending up to 500 km per pride. This massive territory was a necessity, not a luxury, given their enormous size and corresponding caloric needs. The fossil record tells us an intriguing story of their social dynamics. While modern lions live in prides of up to 15 individuals, American lion social groups appear to have been smaller but more efficient. Bone assemblages at key sites like the Page-Ladson site in Florida and the Rancho La Brea deposits suggest groups of 4 to 6 adults working together with devastating effectiveness. And this seems evident in how they navigated their environment. Despite being common, their remains are surprisingly rare in tar pit fossil deposits. It suggests a level of environmental awareness that set them apart. They seemed to recognize and avoid those natural traps better than other predators. Their range stretched across North America, from Alaska to central Mexico. They shared that territory with mammoths, mastodons, giant ground sloths, and even early humans. I've read studies suggesting these massive cats left quite an impression on those early human cultures, maybe even influencing their art and mythology. Then, about 12,877 years ago, it ended for them. They disappeared alongside many of North America's large mammals. The timing lines up with climate changes and the expansion of human populations. The exact cause is debated, of course, but it was likely a combination of those factors: changing environments, dwindling prey, and increasing press from humans. But then there was another prehistoric ruler, this one of the sky. Imagine a creature with massive wings casting a shadow, sending potential prey into a chaotic frenzy. This was Quetzalcoatlus. Discovered in Texas in 1971, the paleontologist who stumbled upon it realized it was a monster. He was so mesmerized by its size that he named it after an Aztec serpent god, and added Northrop, after an aircraft company. Quetzalcoatlus northropi, conqueror of the skies. It's widely known as the biggest pterosaur, the largest flying animal in history. Despite its size and cohabitation with the Tyrannosaurus, little is actually known about its biology. It was once thought to have a wingspan wider than an F-22 fighter plane, but today, paleontologists believe it was closer to 10 to 12 meters, still larger than an F-16. And it stood roughly the same height as a giraffe. Some researchers believe it may have weighed close to what a grizzly bear does. For years, Quetzalcoatlus was considered the largest pterosaur. But recent discoveries of larger species have challenged that, such as Hatzegopteryx, a pterosaur from Europe with a similar wingspan, but greater weight and a bigger skull. Still, Quetzalcoatlus remains the largest pterosaur to have flown over North America. This magnificent creature lacked feathers and a tail. Instead, it had coarse hair covering its body, giving it a striking look. And it was toothless. Quetzalcoatlus. The name itself conjures an image of something immense, something almost mythical. And in a way, it was. Imagine a creature with the wingspan of a small plane, soaring through the skies of the late Cretaceous period. It's hard to believe such a thing truly existed, but the evidence is there in the fossil record. This wasn't just some oversized bird. Quetzalcoatlus had an extraordinary metabolism to support its way of life, showing a resemblance to other pterosaurs. For a long time, scientists assumed it was cold-blooded, like other reptiles. But we now believe that Quetzalcoatlus was, in fact, warm-blooded and quite active. Whether warm-blooded or cold, it's fair to say Quetzalcoatlus probably wasn't winning any beauty contests. Contrary to what some might think, it seems unlikely that any modern flyers are its direct descendants. This creature had a long, pointed beak, much like a modern stork, but without the hooked tip. Further excavations revealed that the skull of Quetzalcoatlus northropi was larger than that of Quetzalcoatlus lawsoni, establishing northropi as the larger of the two species. Quetzalcoatlus also possessed the ability to rotate its head a full 180 degrees. I can only imagine how useful that would have been for spotting prey or evading ambushes. This remarkable head rotation even led some scientists to speculate that Quetzalcoatlus may have lived and hunted primarily on the ground. The idea was that it was simply too heavy to fly and better suited to terrestrial life. This flightless theory, which emerged around 2010, never really gained much traction though. Almost all paleontologists now agree that Quetzalcoatlus was indeed capable of flight. This consensus is largely due to a recent discovery. Unearthed bones suggesting that Quetzalcoatlus had very light, almost potato chip-like bones, which may have made flight easier than we previously imagined. This revelation, however, presented researchers with a new set of questions. How did Quetzalcoatlus take off from the ground? And how exactly did it fly? Many theories have been proposed. Some paleontologists suggest that this enormous reptile launched itself into the air by flapping its wings, or perhaps by lurching forward on its wingtips, much like a vampire bat. Others believe it may have crouched before launching itself as high as 8 feet into the air, giving it enough room to spread its wings and take off. Its secret weapon, apparently, was its strong hind legs, which provided the massive push required to jump. One study even suggested that Quetzalcoatlus was a remarkable flyer, engaging in brief powered flights before gliding, potentially reaching a top speed of 80 miles per hour. And it could sustain this for days, giving it an extraordinary range. Despite its overall size, the torso of Quetzalcoatlus was extremely dense and packed with massive muscles. It's thought that one of these giants could take off with just a single leap and maintain its altitude with only a few flaps of its wings. After launching, they could probably fly non-stop for nearly 10,000 miles, simply flapping occasionally to maintain altitude and course. Its short wings were made of tightly packed muscle fibers, ensuring both flexibility and strength, and allowing for precise adjustments in the air. The extraordinary flight techniques of Quetzalcoatlus even inspired a Johnson Wax-sponsored mission to construct a model flying machine to test flight simulations. The model, about the size of Quetzalcoatlus lawsoni, had a basic computer acting as an autopilot and successfully demonstrated the effectiveness of these flight techniques. Quetzalcoatlus and other Azhdarchids have hind limb proportions more similar to modern running mammals than to their smaller pterosaur cousins, suggesting they were uniquely suited to a terrestrial lifestyle, even though they were quadrupeds when on the ground, like other pterosaurs. All of this has naturally led to a great deal of study about the lifestyle and feeding habits of Quetzalcoatlus. It's widely accepted that this flying giant was a carnivore, though exactly what it ate has been a subject of much debate. Douglas Lawson, the scientist who first discovered Quetzalcoatlus, initially suggested that it scavenged on the carcasses of titanosaur sauropods, much like a marabou stork. His reasoning was that the fossil was located far from the coast, with no signs of large rivers or deep lakes nearby. However, this scavenging idea was debunked in 1996. Scientists pointed out that, unlike the hooked beaks of specialized scavenger birds, the lower jaw of Quetzalcoatlus bent so steeply downward that even when fully closed, a significant gap remained between it and the upper jaw. An alternative theory proposed that Quetzalcoatlus fed like modern skimmers, cleaving the waves with its beak and grabbing fish in midair, thanks to its long neck vertebrae and toothless jaws. While this idea gained widespread acceptance, it wasn't scientifically tested until 2007. That study revealed that for such massive flying creatures, the energy requirement for skimming would be prohibitively high due to considerable drag, making it impossible for Quetzalcoatlus. A year later, another study suggested that the remains of Azhdarchids are not found close enough to large bodies of water to support the skimming theory. Scientists found further evidence that the anatomy of Quetzalcoatlus is quite different from that of any known skimmer. A skimmer's neck is designed to absorb sudden impacts, but Quetzalcoatlus lacked these adaptations. In fact, they would likely break their necks simply from the strain of attempting to push their lower jaws through the water. Instead, their anatomy is more similar to modern storks, suggesting that they most likely pursued and hunted small animals on land. For a time, Quetzalcoatlus and its relatives were viewed as giant vultures, scavenging the carcasses of dinosaurs and other dead animals. But, with the passage of time and continued scientific advancements, we are slowly piecing together a more complete picture of the habitat of this unique creature that once ruled the skies of the late Cretaceous period in North America. In the skies, Quetzalcoatlus likely shared its domain with other pterosaurs like Pteranodon and Nyctosaurus, coexisting within these extinct ecosystems. The thought of encountering such colossal creatures, including Quetzalcoatlus, does make me grateful to live in a time beyond their reign. I find it hard to imagine a world that massive.